So in this presentation I will show you how to do a derivation for LR circuit which is going to be acting as an integrator and differentiator. Like a CR circuit, the LR circuit is also going to be acting as a integrator and differentiator. So these are nothing but two mathematical operations which can be performed by using LR circuit. Okay. So for example, here I am going to start with the integrator. So in case of integrator, okay, the output is taken from resistor. Okay, so this is nothing but the series combination of LR circuit. So this is nothing but L and it is nothing but R. So here output voltage is taken across resistor and this is nothing but the input. Okay, so here the output is nothing but the integration of input. So this is called as LR circuit, which is going to be acting as a integrator circuit. So here I will do the derivation. So here I am going to first of all apply the Kirchhoff voltage law. So according to Kirchhoff voltage law, so according to Kirchhoff voltage law, the total supply voltage, this is nothing but the input voltage signal. So this should be equal to the sum of remaining voltage drops. Nothing but the total supply voltage VI should be equal to the sum of remaining voltages. Nothing but the voltage drop across the resistor plus the voltage drop across the inductor. So according to Ohm's law, the voltage drop across the resistor is nothing but V equal to IR. So V plus nothing but V equal to IR. So IR plus the voltage drop across the inductor is L di by dt. So this is according to Kirchhoff voltage law. So we have applied to LR circuit. So at high frequencies, so when input signal frequency is high, okay, so when input signal frequencies are high, nothing but at high frequencies input, the voltage drop across the inductor will be maximum. Okay, so that is nothing but L di by dt. The voltage drop across the inductor will be maximum when comparing with the voltage drop across the resistor. Okay, so here you can take L di by dt, that is greater than IR. So when comparing with this value, you can neglect the IR. Okay, therefore the input of voltage is nothing but just only di by dt. Okay, so Vi equal to L di by dt. But here we are taking actually as the output voltage is taken across the resistor. Okay, so from the circuit diagram we are taking the output voltage across the resistor. Okay, therefore the output voltage across the resistor according to Ohm's law, it should be equal to V equal to IR. Okay, because we are taking the output voltage across the resistor. So here I am going to differentiate on both sides. Okay, so dV naught by dt, R is a constant resistance, so di by dt. Okay, for example, if I take this one as equation number 1, okay, so I am going to substitute equation number 1. Okay, so from equation number 1 I am going to substitute di by dt value. Therefore output voltage dV naught divided by dt equals to R into di by dt value. So di by dt value is nothing but Vi by L. Okay, or you can write dV naught equals to R by L into Vi dt. Okay, then integrate on both sides. So integrate both sides. So which is equal to V naught. So R by L is a constant. So R by L integration Vi dt. Okay. Therefore here the output voltage is nothing but the integration of input. Okay. So this is nothing but LR circuit which is going to be acting as an integrator circuit. So V naught equal to R by L integration of Vi dt. Okay. So in the next topic, the next part of this heading, so that is nothing but LR circuit as a differentiator. Okay, the same circuit is going to be acting as a differentiator. So here, instead of taking the output voltage across resistor, so we will take the nothing but output voltage across the inductor. So this is nothing but resistor, so this is nothing but inductor. Okay, so previously we have taken the output voltage across the resistor, now we are taking the voltage across the inductor. Okay, so this is nothing but output voltage, so here input voltage, the series combination of RL in which the output is taken from the inductor. Okay, so again I am going to make the use of again Kirchhoff law. So according to Kirchhoff voltage law, the total supply voltage, so here the supply voltage is nothing but our input signal voltage. Okay, so the total supply voltage should be equal to the sum of remaining voltages. So here we have only two components, therefore the total supply voltage should be equal to the voltage drop across the resistor, so that is nothing but according to Ohm's law, V equal to IR, plus the voltage drop across the inductor, so that is nothing but L di by dt. So this is according to Kirchhoff voltage law. Now here I am going to write this equation for low frequencies. So at low frequencies, nothing but when the signal frequencies are very low. Okay, so at low frequencies, the voltage drop across the inductor, okay, the voltage drop across the inductor now can be neglected because it is very less when comparing to the voltage drop across the resistor, that is nothing but L di by dt is very less than IR. Therefore this equation now can be written as Vi equal to just only IR. Okay, so Vi equal to IR. At the same time, here we are taking the voltage. Okay, so from this equation, I equal to Vi by R. But here you can see from the diagram as the output voltage. Okay, so we are taking the output voltage across inductor. Okay, so across inductor we are taking, therefore the voltage of across the inductor is nothing but L di by dt. Okay, therefore output voltage equals to L di by dt, nothing but d by dt. So where I am going to substitute this I value. Okay, Vi by R. Okay, so R is a constant, so here R is a constant, so you can take out from the differentiation symbol operator. Therefore V naught equals to L by R. Okay, dVi by dt. So here you can see the output voltage is nothing but the differential form of the input. So in this way an LR circuit can be used as a differentiator and integrator.